Welcome back, mathematicians. This time I want to talk about geometric sum and series. So last time we talked about arithmetic sum and series. This time it's more geometric. So what I mean by that, instead of pluses and minuses, this time I'm talking about multiplying to get the next term. So in this case, I want to start with a couple formulas just to get us started. And these are abstract, kind of out of context, but we'll get into detail in our first example. So I'll start with the rule of geometric sequence. What it is it's how to find that next term. So like arithmetic sequence and series, if I want to find the fifth term or something, I'll put a 5 for my n, and I'll change what's called the common ratio. So instead of having a common difference, this time I have a common ratio. And we'll see what that looks like in our next slide. For the sum, so for right now, we won't talk about infinite series. I'm just going to talk about finite series. And what I mean by that is that I'm not going to talk about geometric series that go on forever, because adding those things up would a lot of times turn out to be a really big number. And again, you'll see it in calculus when you get there. And it's actually really neat when you finally get to learn about that kind of stuff. But for right now, we're just going to talk about finite series. So we're going to stop at some n. So I'm going to give you some value of n that we're going to stop at so we can figure those out. Okay, let's take a look at our first example. In our first example here, I have 7, 21, 63, 189. And we're going to start by finding the common ratio. Let's actually find the common ratio and find the fifth term, for example, okay? So what I'm going to do first is find the common ratio. So what I'm going to do is I'm going to take two terms, right, just like we did before, 21 and 7, say. I'm going to divide the two, 21 divided by 7, and I get, if I reduce both of those, 3 over 1, or 3. Right, and I could do it again. Say maybe I don't believe what I'm seeing, and I want to check just to make sure. It's good. Mathematicians always want proof. So I'll have 63 over 1, and again I get 3, and I can do it one more time. 189 over 63. So I'm taking one term and the term before it and dividing the two, and again I get 3. And I really want to double check that I put everything in the right order, and make sure it makes sense, right? So if I multiply 7 times 3, am I getting 21, right? And say I got 1/3. 7 times 1/3 doesn't make much sense because I would get a number smaller than that. So that's not the case. So this number makes sense as a common ratio. So I'm going to use that and try to figure out what my fifth term is. Okay, so let's take a look. I'm going to use that formula from before. I want a to the fifth term. That's a 5. That's a to the fifth term. Is going to be my first term, right? A1, which in this case is 7. I'm looking for my first term here. So that's 7. And then I put the common ratio in. So that's 3. And I put to the power of, again, n minus 1. So in this case, it's 5 minus 1. Okay. And what we should do is look in the parentheses first. I'll see that I can't do anything within there. I can do something with my exponents, though. So exponents is the next thing in the order of operations. 5 minus 1 is going to give me a 4. Okay. So 7 times, and then I think, let's see. I think what happens first, right? Does my exponents happen first or my multiplication, right? And if you remember your PEMDAS or your order of operation, exponents always happen first. So I should put my 7 down. And then I'll do 3 to the fourth power, which is going to be 81. Right? Now all I have left is a multiplication problem. Not a problem. I multiply those two things together using my calculator, or I can write out a multiplication. But that's going to be 567. So that is my fifth term, right? So in order, it goes 7, 21, 63, 189, and then 567. Okay, you see how this guy is growing very rapidly. So the next part, I'm going to use the same numbers as before, that same sequence, and I'm going to make it into a series, right? So I'm going to have, in this case, 7 plus 21 plus 63 plus 189. And I could go more, but I'm going to try to keep the numbers kind of small just so it fits on the screen a little bit better. And I'm not sitting here writing just long numbers. So anyway, if I want to find the sum of this series, I definitely have a formula for that. So in this case, I'm looking for the first 4 terms, right? So the first 4 terms, that means my n is going to equal 4. So I'm going to say the series of to the 4th is going to be equal to my initial number, 7, a1, to the 1 minus 3, because that's my common ratio, to the 4th power, that's my n, all over 1 minus 3. Okay, so let's try to figure this thing out. Again, order of operations. So within here, I do my parentheses first. I take care of my exponents within there. So I go 7, that doesn't change. 1 minus 81, all over 1 minus 3. And you might be thinking, well, it looks like we have some negatives in there. And that's true. But the top is negative and the bottom is negative. So in the end, those things are going to end up canceling out. So I'll have negative 80 on top. I'll have a negative 2 on the bottom. Again, a negative divided by negative, that's going to give me positive. So that's going to be positive 40 when I divide those two things out. And that's going to give me 280, right? So the sum of the first 4 terms, so the sum of this series is going to be 280. All right? I think it's your turn now. Let's give it a try. So on this try it, what I want you to do is find the sum of the first 6 terms using the sum of a finite geometric series. So first things you're going to do is going to find a common ratio, then you're going to find the next 2 terms, and then you're going to add all those guys up together. Give it a try. I look forward to seeing it. And I'll catch you on the next video.